Hello folks, this is Mr. Messman with the Flipped Classroom Vodcast. Music of Waters, number 9. I can relate latitude, sunlight, seasons, and climate. Now what you're seeing here in this time lapse that I made is the sun creeping along the ridge line on the winter solstice, December 21st. Where I live in a canyon, that's all the higher the sun gets on about December 21st. And we see it for just a few minutes, really, skimming through the trees. And the rest of the time, it's pretty cold and pretty dark here in the canyon. And that's because the sun's at such a low angle. On the winter solstice, or the December solstice, here in the northern hemisphere. So let's take a look. Here's a diagram of the sun and the earth orbiting the sun in a counterclockwise direction, looking from the top, from the north. Here's the axis of the earth, tilted 23.5 degrees. Now the sun's rays at this position on the left are shining more on the northern hemisphere. Let's try that again. And so on the left side is the side of the earth in shadow. The night side of the earth. And the North Pole is in sunlight. When is the North Pole in sunlight? For the longest time, well, it's during the summer. And that would be starting in June. And this position is the June solstice, or what we call the summer solstice. On the right side of the diagram, we have the opposite situation. Now the North Pole is tilted away from the sun, and there's the night side. And now the South Pole is completely in sunshine for 24 hours. This is the December solstice, or what we call the winter solstice in the northern hemisphere. The other two positions have the sun shining directly on the equator, and the top one would be the equinox in March. We call it the spring equinox, and the bottom one would be the equinox in September, our fall equinox. Now let's look at it from another perspective. Here's a diagram of the Earth and shows the sun in 3 positions. There's Missoula, about halfway between the equator and the North Pole. If we look at the sun during summer, spring and fall, and then winter, we see the angle of the sun has changed. When is it the lowest? Well, on the right, we have the winter. Now, here's the sun shining on a flat surface. Winter, and summer, and at the equator. As the angle of the sun gets smaller, the area of the little spot of sunlight gets bigger. Therefore, the light is more spread out. What that means is the Earth receives less sunlight, our part of the Earth, in the winter. Now notice that the sun is never straight overhead in Missoula. One more big factor with sunshine is how long it's up. And there's a big difference on the 2 solstices in the amount of time the sun is actually in the sky during the day. So on the December solstice, you can see 8.5 hours between sunrise and sunset. But in the June solstice, there is almost 16 hours between sunrise and sunset. Now, one more really big factor in the climate of Missoula is the rain shadow effect. So here's Missoula on the right, on the east side of this drawing. And over on the west is the Bitterroot Mountains. The prevailing winds, the prevailing westerlies, flow from west to east most of the time. And when they hit the mountains, they flow up and over, and then down into the Missoula Valley. As the air rises up the west side of the mountains, it cools. And eventually it cools to the dew point. And when it reaches the dew point, what do you get? Well, you get clouds. And those clouds will rain and snow on the mountains. So the air that ends up coming over the mountains is drier. It's dried out a bit. And when it sinks, it warms. So Missoula gets warm, dry air from over the mountains. Therefore, Missoula is said to be in a rain shadow from the Bitterroots. And it is warmer and drier here than it would otherwise be. Thanks for watching, everybody.